Thanks for joining us again today, guys. We're going to be covering the RPO sequences today, in particular, the phase change sequence, which is a part of the RPO Specialized folder in the new RPO sequences. So if I go over here and look at the RPO Specialized folder, there is this phase change. So that's what I'm going to be covering today. In taking a look, to start off my scenario before we get into those properties, I have an initial state, but this initial state is relative to a chase satellite, and my whole goal for this is to be rendezvousing closer to my target satellite. So if I come right over here, you'll see, if I take a look at these guys, you'll see in the GeoBelt, I have my RPO starting off, and then over here, we have my target. So the whole goal here is going to change my phase of an orbit. So it's going to do a rendezvous and go towards this target satellite, where it's then going to settle at the specified phase angle offset for the sequence. So if we go back to this phase angle and I zoom to my target satellite, I'm actually ahead of my target in this orbit. So what I'm going to end up doing is going to a location of 1 degree away from the target. So right now I'm like 10 or 15 degrees away. So we're going to basically perform a maneuver to raise our orbit in this case. If you are behind it, you'd be lowering, but you can also specify the direction. So based off your initial location, it will specify whether you're raising or lowering. So you need to start off in the same orbit already. So that's one of the initial conditions. You need to start off in the same orbit. It's going to perform a burn to raise your orbit or lower, depending on which way you're going. And then it's going to drift towards that target. So if I have a circle, it's going to make a bigger circle or a smaller circle and then drift towards the target. And then it's going to exit and then match the original orbit as you started off in. If I had an ellipse, it would make a bigger or smaller ellipse. So it's going to maintain that eccentricity and argument of perigee with respect to the target. So it's basically going to make a smaller or larger orbit of the same size and then drift towards it. And the way you can control that is with this phase over here. So where do I want to end up? In this case, I want to end up 1 degree away from my target satellite over here. I can perform the burn's going to be done with impulsive maneuvers. You could also switch this to be finite. Which engine model would you like to do? In this case, just rendezvous engine. Well, my RPO, which matches the same over here in my object browser. This is called phase change. Phase change is over here. So if I do have multiple of these, just make sure to update this parameter right here. And then if I'm going, so instead of being, in this case, I'm ahead of my target. So I'm going to go in the minus velocity direction to go towards it. That's the shorter direction in this case. Whereas if I were behind it, I could change this to the plus velocity direction. It also depends on where you are with respect to target. Since I'm already kind of close, the shorter distance, in this case, just go in the minus velocity direction. But that might not always be true. You can just pick what direction you're going here. All right, and then the max number of revs, since this is going to be making a larger orbit, the longer I have in revs, the less fuel it's going to be used. So it could take up to 10 days to get towards my target. All right, so if I take a look at my 3D window over here, I have an RPO. It turns out that even though I'm in the same orbit, there's a little bit of a cross-track component, and a little bit's okay. But if I expand this phase change over here, what's going to happen, it's going to propagate to my drift start. In this case, I think it's going to get triggered on this apoapsis condition over here. And then from there, once it's there, it's going to burn. It's going to start this burn. It's going to raise my orbit. And because I'm raising my orbit, I'm slowing down relative to my other target satellite, which causes me to drift backwards. So if I were to go ahead and slow this down and animate, I'm going to speed up just a little bit. This is waiting to enter that phasing loop, so it's going to wait just a little while. Then it's going to perform a burn to raise my orbit in this case. It's going to stabilize up here. It's not trying to do anything with the cross-track direction. That's why there's a little bit of this side-to-side motion up here. So it's not going to try to get rid of that, but we're going to drift towards my target. Just going to speed up this process a little bit. And then this, as you see, took right around 10 days or so to complete, it's actually 12 days because of the entry and exit, but it's drifting for about 10. And then wait a little while to actually enter it. But it's drifting. And then once it gets close to my target, since I'm ahead of it, I want to stop 1 degree in front of my target. Right here, it's going to initiate that downward burn to go back down and try to match the same orbit as my target satellite. Once again, it's not going to try to get rid of any cross-track components, but it will match the in-track location offset, which is controlled by this phase degree. It'll make sure your orbit period's roughly the same too. So it'll get rid of any sort of radial offsets there. And then it will stop down here. Okay, so that is the phase change. Thanks for joining me.